Hi guys, thank you for joining. This is Marcos Anasibia here. You are at the Oracle Machine Learning office hours. So today we're going to look at the OML Notebook templates for machine learning regression. And I have with me Sherry LaMonica. She's on the call for anything you guys need on the Q&A. So anything, any questions you guys might have during the presentation, please feel free to put them in the Q&A, okay? All right, so what do we have for today? I wanted to do a quick 2021 year in review in terms of what we have done with Oracle Machine Learning office hours. Then talk about the upcoming sessions we have. And then I'll work on follow along Oracle Machine Learning notebooks for ML regression. So the idea is that if you guys have access to an autonomous database, you can go and do exactly what I'm doing. So you can follow along and hopefully get the same types of results. And you can see, you know, even down to the performance and different things that you might have. And then if you have questions, again, feel free to send them our way. All right, so Oracle Machine Learning office hours in 2021. Coming from 2020, we wanted to increase the frequency of the sessions and do more sessions than we did. So we were trying to go weekly. That was not always possible for sure. Depending on the week, we had, you know, other events to attend or things along those lines. So we ended up with a reasonable number. We ended up with 36 sessions out of the total 55 sessions that we have had so far to date. So 36 sessions in 2021. The average attendance was 110 people. So that's a great attendance on any of these office hours, as you guys can imagine. And then we ended up doing a lot of things actually in 2021, right? We did product launches. So we launched OML4Py, OML AutoML UI, and OML services on autonomous database, and also OML4Py on 21C on premises, right? And then we ended up doing 3 90-minute hands-on labs. We did 6 sessions where we had feature highlights, right? So it was specific features of OML. And then we had 5 usage highlights, which actually were, you know, internal customers, right? Using OML for different business purposes and different technical purposes, right? I think all in all, it was a great year. And I would like to thank you guys. This is our last session for the year. We are going to be providing a recording of this session today, plus the classification session early next year, okay, in early 2022. So that's that. Really just wanted to say thank you guys for being with us for all this time. And more stuff to come for 2022 for sure. So today's session is going to be the regression. And then the next sessions are going to be clustering, feature extraction 1 and 2, and time series. We're going to still deciding the dates for those, but for now, you have in your calendars, if you take a look at the sessions, you can see in Ask Tom that these sessions are on. So we're going to have a January 11 and then a January 18 session for these notebook templates. Okay. Now, that doesn't mean that you guys can't send us suggestions. I think it was clear the last time that we talked that you guys can send us suggestions, can post questions in Ask Tom. And now we have also an eye on
Stack Overflow.
If you have any questions, that's another forum that we can monitor and we can look at. So if you guys have, you know, different types of questions on OML, just make sure to tag that as OML or Oracle Machine Learning, and we're going to find it and help you guys there as well. All right, so without further ado, let's check the templates for machine learning regression. So there are 6 specific regression demos that you can find in OML. We are using the GLM, the neural networks, and the support vector machine algorithm to run those. So we have the Python examples and we have the SQL examples. And to find the templates, right? I think the last time we talked about it, And I'm going to go and show you guys how to get there. But basically, the idea is once you're inside your Oracle Machine Learning, you'll be able to find the examples at this place, this location, right? Either in the quick actions menu on your home menu, or you click on the hamburger menu and then you see there's a templates. Under templates, there's examples there, okay? And then for you to locate the regression ones, all you have to do is just start typing regression there, and it's going to filter out of the 74 notebooks that are there in the example templates. You're going to see these 6 ones, okay? And then you're going to be able to click on the lib or around the example and not click on the name itself, right? But click on that example, and then we can start it up. All right, so let's take a look at a couple of examples there. Right here, then, I typed regression, right, on the example templates, and then this is what comes out, right? So I get the GLM, neural network, support vector machine, and then what I want to do is I want to check, actually, I'm going to start the other way around. The last time we started with the Python, I'm going to start with the SQL one here, and I'm going to get the regression neural networks one. And the reason is because there are some tricks there, especially when it comes to naming the activation functions. So remember not to click on the name, right? Not to click on the link on the name, but click around it, right? Somewhere else, and then you see this turns blue, right? The external area turns blue. So you click on Create Notebook. And now we can give it a name, right? And then you can put comments if you want, right? And then we can say just OK. Right, so I got my confirmation on the top right that the notebook was created. And then I can go here on the notebook. So I can click on the hamburger menu, go to notebooks, and I'll be able to find my neural network example, okay? So let's open that up. All right, so as always, it's very good to check the interpreter bindings, right? When you open an example. So we want to click on that little gear here on the top right, right? Interpreter binding. And make sure that you got one of these guys selected, right? I like to select the medium, right? Because the high is potentially too radical, and I might step over other processes that are running on the database, and I don't really need it. It's not going to make it any faster, especially on these sample sizes, right? So you can just select the medium, but you make sure that you have one checked, right? If this is unchecked, then you're going to get an error if you try to run a SQL or a Python or a script, right? Paragraph. So let's make sure that you have one of those and save. Okay, so now I'm going to run them all, right? So I'm click on run all paragraphs. And the reason is, you know, you can see that these guys were run back in August, right? So I want to run everything now to have it a fresh look at everything. And if I want to add, you know, one comment or want to run something else, I got the tables, right? Created, I got everything created. Remember that these notebooks were created or were executed by us, right? On a test environment. So the results you see here, right? Whenever you're listing, if it says August, right? It might not have been created. So maybe you did not have these tables yet on your environment, right? So you want to make sure that you run everything, okay? So we're creating just here a table, right? A customers 360 table based on the supplementary demographics table on SH schema and the customers on SH schema. And we're going to build that neural networks for predicting years of residence, right? So that might be interesting, you know, if you're trying to send marketing to a person to know how many, you know, how many years the guy has been living on a certain location. It always is interesting to know all of that. So if I want to do a single layer for neurons with a default activation function, right? All you're doing here is just saying a single layer, one layer, layer one, and I'm saying neural networks nodes per layer 4, okay? And that I'm putting that on the set list, right? So this set, the settings list, right? Variable here in the PL SQL. So I'm setting those things. And then when I call the create model 2, I'm saying this is my model name. So remember, you have to have that unique. So what we did is we dropped it before, right? So I dropped any model that has that same name so that, you know, I'll make sure that this guy doesn't give me an error, right? So the model doesn't exist yet. So I can give that model name right there. Oh, by the way, there is also a function to rename a model. There's called a rename underscore model. And that guy can work to version your model. So if you're not sure, instead of dropping the model completely, you could rename the model. And if there is a model already with that name, you can version that first. So you could, you know, version that or rename that the old model that was there to underscore old or whatever, or you know, or change a version number, and then this one becomes the new one, right? So and then right here I'm saying the mining function is regression. This is my training data, right? So I'm loading all the training data, and this is my list of settings. So this is an important list of settings, right? And then we got a case ID, right? So what's the case ID and my target, right? So years of residence. And that's great. So that runs like that. But the neural networks have a lot of interesting overrides that are possible, right? So there are not only overrides that are possible for the neural network algorithms themselves. So you can click on here to go to see the full documentation, but there are also shared settings, right? So some of those shared settings are things like row weight, right? Or the missing value treatment as well, right? So these two guys here, the two first guys, are common, right? Now, down here, what we wanted to show you guys is an example of how to call out the different activation functions. So say now you want to do 3 layers. I want to do 8 neurons, and then the last layer, I want to have 2 neurons, right? And that's the last layer before the output. So right here, this is the way to call out and explain those multiple activation functions. Now, notice that this is critical, right? Notice that there are 3 single quotes here, and then you have the 2 quotes closing, 2 quotes opening, right? The 2 quotes and 2 single quotes, and then you have the triple single quotes at the end, okay? So that's why it's important for you guys to pay attention, right, to these things, because this can give you a lot of headaches, right, when you're trying to run this, and you might be, you know, doing it wrong, or you might trying to do double quotes and things along those lines, right? So sometimes it is complicated, but we're making sure that you guys have an example here that will do the right thing, okay? And then other things, the regularizer, the held aside ratio, right? Max fail, the lambda for the regularization, number of iterations, the tolerance. So there's a lot of other things. And then if you specify, you can specify the solver. So if you specify the LBFGS solver, then you have the history depth, right? And then with that, you can also change the gradient infinity norm, right? Tolerance for LBFGS as well. Finally, the scale as well. So you can enable or disable the scale Hessian on that. So there are, again, many of these options. We try to copy from the documentation so that you guys don't have to go there, right? And perhaps get lost there. So we want to make sure that you guys can see these options here, right? So right now, then, what we're doing here is using a single layer with 4 neurons, but I'm specifying the activation. So what happens is, you can see I have 1 hidden layer, and I have 4 nodes, and I specify the log sigmoid activation function, okay? So that is one option. The other option here is I'm saying, as I had that in that example, 3 layers with 8 and 2 neurons. So that's what I wrote here. And then I have these activation functions here, right? you can see that I can play with the activation function. So I have a hyperbolic tangent here, right? I have a log sigmoid here. I have an arc tangent here, right? So you have these three different types of activation functions for each of the layers, right? So you can play with the different activation functions that are available, and then you can put them in any order, right? And then you have all the other options here that you can add and specify, right? So again, this is probably not a simple example, right? This is just how to use all of these options in one, in one place, so that you guys can have ideas on what this looks like, right? So, and at the end of the day, I have another example here with 16, right? 16, 8, and 4, and then default activations. So you can just leave all of them with log sigmoid, right? For example. And then this is now displaying the model setting. So once the model was built, right? So someone built the model and you see that model available, you can actually query that model from the user mining model settings, okay? So then in here, you can actually see what were the settings that were created, right, on that model. What are the settings that exist today on that model, right? And the same thing you can check for the model signature. And this is in the user mining model attributes table, okay? So in there, you can check these so you can see, what is the model doing, right? In terms of the categorical or numerical, in terms of the inputs, right? There you can check the different model views available, right? So we can see these model views. You have the neural network weights, you have the global value, name value pairs, normalization and missing value handling, computed settings, and model build alerts. So something like, if I query select star from that VGNN, right? That VGNN is this one, the global name value pairs. This is what basically you see there, right? So number of rows, iterations, the loss value, and whether model converged, right? And then you see attribute weights, right? So this is not the variable importance, right? This is the attribute weight. So the weight of each of these attributes, right? And then you got to remember, this is a neural network. So you got all these connectivities, right? From layer X to layer X. So layer 1, right? So you have all of these different connectivities, right? From layer 0 to the 14. So there's a lot of different weights, right, that you will have here on a neural network. And then you can do something like this, for example, right, to have an idea. But again, this is giving you the first layer of attributes, right? So it's not giving you attribute importance. It's just giving you the first layer of the attribute weights. Again, just to have an idea, right, of how these things look like, right? So you can apply then the neural network to predict years of residence, right, with the prediction details. So in SQL, this is basically how it looks like, right? Remember that we use the XML table, right, to get the details or process the details in a better way so that they look nicer like that. So I know this customer, 100,003, have a prediction of 4.2 years of residence. And the reason why is this variable is like that, right? This household size is 2, customer income level is K, customer year of birth is 1969, right? So that's basically giving you the reasons why we believe that this is the predicted years of residence, right? And you can see here that the predicted versus the actual. So we predicted 4.2. The customer actually had 6, which is not that bad, right? Not that far away. 5.8 to an actual 5, 3.6 to an actual 3, 5.1 to an actual 5. So it's not really that bad. So, and then we can basically check some of the model quality statistics. So this is something we added. I don't think we had these guys before. So we added these coefficients of determination, the R-square, right? The mean absolute error, the mean squared error, and the root mean square error calculations, all of them right here in SQL, so that you guys can see as just a standard SQL running that prediction, right? So what we're running is the actual versus the predicted, right? That's all we need. to compute these things. So, right, so we're creating the table right here, and then we're doing the prediction, and then with that, we're computing all of this. So it's very, very nice to see all of these capabilities, right? That normally a statistician, a data miner, a data scientist will like to understand about a model. And then finally, we can do some plots. So the basic plots for regression, right, would usually would be the prediction versus the actuals, right? So you would want to see something like a straight line, right, with the larger number of customers, right? And then just so that we had an idea, we plotted as well the household size, just to see whether that made a lot of difference, right? Because potentially you might have something like here, right? So the household size of 1 is probably more widespread, right? It's maybe harder to predict than the other average ones, and also there's a big error here on number 2 and 3, right? So this might be even harder, but and then we like to plot the predictions versus residuals as well, right? So that in theory, ideally, these would actually be a random, a random distribution across 0, right? So this is not the case. We can see all of these straight lines here. So definitely it is something that we're not considering in our model. Our model is not capturing all of the correct attributes. Maybe we're missing a specific attribute or a transformation on one of the variables that we have, but we can see that there is a clear pattern that is not random noise, right? So that definitely tells us that we should look for an improvement on that model, right? And then there is another option. You can actually create a table or a settings table, and then we give you guys an example here, right? It is more verbose for sure, but we're creating a table here called NNR settings, and then that you can use that table, right? So if you do this, you can use that table to build a model using the create model now, this time without the 2, right? The create model 2 can use straight the information from that vset list, but the create model, this is the older version of the interface. It takes a settings table, right? A settings table name as an input. So again, that's something that you guys can see as an option here, okay? All right, so if you go back to our examples then, now real quick, we can see that we have the same thing is going to happen to the Python, right? So if we go to Python, I'm going to go real quick into the Python regression for neural networks. And you can see that I clicked on it. I didn't even create one just because I only want to show it to you guys real quick. But there is just a minor difference, right? And the minor difference here is when you declare the model, right? The activations. So look at this thing, right? So for Python, you actually need a double quote on the beginning at the end, and then a single quote separating each of these the neural network activation functions, okay? So I just wanted to show you guys this because, again, it might be confusing, and if you guys are not paying attention, that might happen. So this is the way to declare that activation functions in Python, right? So you gotta use that double quote in front, and then the single quotes inside, okay? And all of the rest is identical here in terms of the models should be the same thing, the same predictions, and you're gonna get the same kind of information here: the R-squared, the mean absolute error, the mean squared error, and the root mean squared error, right? So you're gonna get all of that here coming from Python directly. We use some NumPy tricks in this component here, okay? And then we do the same plot, and we do the plots using matplotlib, and you can see that this is definitely different, and this is definitely, you can see the same patterns, right, that we were seeing before that are not random. All right. So At the end of the day, that was what I wanted to show you guys. If there are specific questions that you guys might have, please let us know. Otherwise, I would like to wish you guys happy holidays and talk to you on 2022. And thank you very much for joining.